Okay, in this exercise, we're going to change the code to pull Bitcoin data and see how much it takes to move Bitcoin by a penny. So now again, these estimates, because we're using kind of a short time period, these estimates can be quite volatile, but here it's saying $66,294 to move Ethereum by a penny. So we'll go ahead and test this for Bitcoin. And instead of actually putting this in here, I'm going to just go ahead and change the code above. Now, I did one thing that is probably not the best, particularly now that I want to change the code, is that I named this Ethereum trades. I should probably just call this generic currency trades. But the idea here is we want to change this here to BTC to pull Bitcoin. This just shows the order book, so it doesn't matter if we change this, but just for completeness, I'll go ahead and change it, and so now we can see, yes, this is Bitcoin, 52,000. But this is what we really need to trade. But change. But I certainly don't like having Bitcoin here and then Ethereum in the name. So I'm going to go ahead and Control H and change Ethereum trade with just general currency trades, right? So we can go ahead and replace, and hopefully that hit everywhere in the notebook, so that now I can go ahead and just simply say run everything. And I'm going to go down here and I'll tell you what, I'm just going to go ahead and change this to BTC, and then say run all. And we'll get an estimate for Bitcoin. So Ethereum 66,000. So let's go runtime, run all, and give it a second. Close that. And we'll get an estimate here. While it's running, I can talk a little bit about the Kalman filter. So the Kalman filter is going to give you a time varying. We got it. We got an estimate, 996. And again, this estimate is somewhat volatile, because it depends. Ethereum has a very deep market now. So the idea here is the deeper, the more liquid the market, the more it will cost to move the price. So I'd say with Ethereum, it's a pretty deep market, so maybe about the same as Bitcoin. Maybe it would take a little bit more to move Bitcoin than it would to move Ethereum, assuming Bitcoin market's a little bit deeper. So I would assume it would have been a little higher than Ethereum. And we can run this a couple times. Like I said, this is it's not pulling in a great deal of historical data, so we can get sort of odd results like this. But this is perfectly fine. So that's really all we need to do, is make sure we're pulling Bitcoin data and then running it through. A little note about the Kalman filter. So the Kalman filter will allow you to sort of estimate a time varying lambda. And this is Kalman filters are widely used. They're widely used in finance. People know them from maybe estimating a time varying beta coefficient. But the idea here is, Kalman filters sort of started in around, or one other use of them outside of finance would be sort of tracking a missile in the air, where you have a noisy observation. And so that's what we're trying to do here. We're saying we observe this relationship with some noise. So the Kalman filter can kind of give us an optimal estimate of that underlying relationship. If you want to look into the Kalman filter, the machine learning libraries like TensorFlow Probability and PyTorch have some great implementations of the Kalman filter. Of course, it's quite easy to implement the Kalman filter yourself, and maybe I'll throw a little Kalman filter in here. So if you're feeling like you want a challenge, then I definitely encourage you to try to implement a Kalman filter, and then what that will do is allow us to get a time varying estimate, because again, the amount that the liquidity of a book changes over time, right? This is kind of the average over the interval. So the Kalman filter will allow you to say, okay, well, how deep is the book throughout the day?